Okay, this is section 1.1. This is one of the sections that is strictly a review. So you do not have to go over this if you don't want, but I wanted to include this just to make sure that if you were having problems with some of the basic techniques in algebra, I wanted you to have a video that represented these concepts. So this is algebraic expressions and models. So we're going to apply the properties of real numbers. So we start off by saying let A, B, and C represent real numbers or real value expressions. Now, these are the different properties that we have. And if you'll notice that for all of the properties that we have, they are only based on addition and multiplication. They are not based, subtraction and division are not included. However, that doesn't mean that we won't include division and subtraction in some of these properties, but we just write them differently. So the commutative property, if you think of commutative like a community, they intermingle. So if you and I are friends, if I'm friends with someone named Robert, well, Robert is friends with me. So A plus B equals B plus A. And the same thing for multiplication, A times B equals B times A. The associative property is what you associate. A plus B in parentheses plus C is the same thing as A plus B plus C that's in parentheses. So notice how our association here was A plus B first, and then we add C equals A plus, and then we add the B plus C together. And the same thing for multiplication, A times B, then times C, and then A times, and then B times C. The identity property refers to what can you do to an equation and not change its value. So for the addition property, if you add 0 to some number, then you don't change the value. A plus 0 is just A. 1 plus 0 is 1. Negative 5 plus 0 is negative 5. Okay, so 0 is the identity element of addition. For multiplication, our identity element is going to be 1. So A times 1 is just A. 5 times 1 is 5. 1 times 5 is just 5. Okay, so for addition, 0 is the identity element. And for multiplication, 1 is your identity element. The inverse property, this is what basically undoes something to get it to 0. So A plus minus A will give me 0. So 5 plus a negative 5 would give me 0. And negative 5 plus 5 would give me 0. For multiplication, our inverse property is going to be A times 1 over A, because the A's are going to reduce to just leave you with 1. Okay, so 1 over A is a multiplicative inverse or the reciprocal of A. Okay, then the distributive property is a unique property because it involves addition and multiplication. Well, I should say multiplication over addition. So A times B plus C, we distribute A to the B. So A times B, and then the plus, and then we distribute A to C. So these are things that I know at one point you did learn about, but probably forgot because we really don't use these concepts much. Okay. All right. Now let's look at applying the distributive property. So the distributive property, we're just going to take whatever is on the outside. So this negative 4 for number 1A, and we're going to distribute to every term. So I'm going to have negative 4. I'm going to go ahead and put this in parentheses, and then we're going to multiply it times everything that's on the inside. So negative 4 times 2x squared minus, and then we have a negative 4 times a 6x plus negative 4 times 5. Okay. And now we clean this up. So this gives us negative 8x squared. These two negatives are going to turn into a positive. So 4 times 6 is 24x. And then negative times a positive is a negative, and 4 times 5 is just 20. And here is our resulting solution for that expression. Now, it's not an equation. These are expressions because we do not have the equal sign. Now, for part B, when we distribute the 2/3, I'm going to go ahead and distribute this through. I'm going to split this apart so that we can see what's going to happen. So we don't panic when you have a fraction to deal with, because a lot of times the fraction is going to end up helping us out. Now here, because of the 27a to the third, that's not a fraction, but if I put it over 1, I can make it a fraction. So 3 goes into 27 9 times. Then we have 2 times 9, which is 18, and the a to the third just hangs on for the ride. Okay. Now 3 goes into 9 3 times, and then 2 goes into 10 5 times. So these are left with 1. So all we have is a minus 3/5 a, and that's it. Okay. Now for part C, we're going to probably would benefit you if you have a calculator. So I don't know if I think the calculator should be showing on the screen. So negative times a positive is going to be a negative. So it's just 0.02 times 100. And that gives us 2z to the 5th. Now, a negative times a negative is a positive. So 0.02 times 50, that's just 1. So that's just a z to the 4th. I don't have to include the 1. Negative times a positive is a negative. So we've got 0.02 times 5, and then we get 0.1. And here is our resulting answer to that. Now, I did not distribute, I didn't show the distribution in B, A and B like I did earlier, okay? All I did was just distribute, okay? All right. Now, let's look at the next section. Okay, now the next part is simplifying expressions by clearing the parentheses and then combining like terms. So it says 2 terms can be added or subtracted only if they are like terms. So what is a like term? Well, like terms are terms whose variable factors are the same. Their coefficients may be different. In other words, this means um, that in order to have like terms, the variables, let me put variable or variables, and the exponents must match. Okay. So when we look at number 2, now the other thing before we start doing this, whenever we are simplifying expressions and we are combining our like terms, we want to always make sure that we write our answer in what's called descending order. Okay, descending order. Let's see, where can I write this down here? Let me just put this down here. So descending order uh, means that you start with the highest exponent and decrease each term accordingly. Okay, so for number two, if we look at number two, the highest exponent that we have, now remember, like terms means the variable and their exponents have to match. So we have these two terms are like terms because they both have x's and they are x squareds. Okay, so these are like terms. So now I want to combine them. Well, this is like saying if I have 18 apples and I put 12 apples back, how many apples do I have? Well, we have 6. And then I started with the x squared because that's the highest exponent. Okay. Now, the net we're going to decrease. So that was degree 2. Now we're going to go to degree 1. I think I said decree. I meant degree. So degree 1 means our x terms. So minus 4x and minus 20x is going to give us a minus 24x. Okay. And then we have one last term. So that's degree 2, degree 1. And the only thing that's left are going to be our constants, which is a plus 3 and a minus 10, which gives us a minus 7. Okay, so it's kind of hard to see. So let me just rewrite this in black. So 6x squared minus 24x minus 7. This is a proper way to leave your answer whenever you are simplifying expressions. Okay. Now, on number 3, when we have multivariables like this, the order that you put this in really doesn't matter. You just want to make sure that you have your like terms together. So this is an AB squared. Well, this is just an AB, same variable, but the exponent on the B is different. So not the same. These are not like terms. That's just a B squared, so no like terms. But here is another AB squared. So these two terms are the same. So let me go ahead and write these two together. Okay. Now, let's see. The next thing that I notice is here is an AB. Well, I only have one AB term, and I'm just going to leave it by itself. So that's just a 3AB. It's not going to go anywhere. And then the last like terms we have are these B squareds. So plus 1/2 B squared plus 1/4 B squared. Okay, now I'm not really going to cut you a lot of slack here because you are supposed to have your calculator will handle adding a whole number and a fraction together. You'll get a decimal, but then you just turn that decimal into a fraction. So let me show you just in case you don't know how to do this. Let me get my calculator out real quick. Because at this point, the last thing I want you to do is to waste a whole lot of time on having to add these kinds I don't want you to waste time on doing this. So, all right. Oh, come on. Okay. Uh-oh. All right. So these are like terms. So I'm going to take in parentheses, I'm going to write 2/3 minus 2. So it's going to give me a decimal. Then I'm going to hit math, and then press number 1 because I'm going to turn that into a fraction, hit enter, and there it is. So that's going to give me a negative 4/3. So we have negative 4/3 AB squared. Our AB, we only have one term, one AB term. And then for the last one, it's just going to be 1/2 plus 1/4. And then there's the decimal. Now you should know that 0.75 is 3/4, but if you don't, you're going to hit math, then select number 1, hit enter. So there's 3/4. And that's going to be plus 3/4 B squared. And here is your answer to this last problem, to that one. Okay. All right. Now, I want you to work on 4 and 5 by yourself. All right. So I'm going to pause the video and I want you to do 4 and 5, and then we're going to do 6 and 7 together. So I'm going to pause the video in 3, 2, 1. Okay. This is what you should have gotten for numbers 4 and 5. So number 4, you just distribute, combine like terms. Now, number 5 was a little bit more tricky, but here's the nice thing. Remember, I told you fractions are not always something to be afraid of. So 4 goes into 16 4 times. 4 goes into 8 2 times. 8 goes into 24 3 times. 8 goes into 24 6 times. Now, since this is a 1, well, 1 times 4 is 4, so that's 4x, minus 1 times 2 is 2, plus 3 times 3 is 9x, and then 3 times 6 is 18, and then you combine your like terms. Make sure that you put them in the correct order. Okay, now for number 6, we have to be really careful here because we have groupings within groupings. Okay, so the first thing I'm going to do is clean up what's inside the bracket. So 2 times 3x, that's going to be a 6x plus 2 minus 5x. Be careful with your signs. That's going to be a plus 20. Okay. Then we close the bracket. Now inside, we're going to combine our like terms. So 6x minus 5x is just an x. And then 2 plus 20 is 22. Okay. Now we have 14x, but this negative sign that's out front of the bracket means I have to distribute the negative. So this gives me a minus x and a minus 22. Then the last step is to combine your like terms together. In this case, these are our x's. So your answer should be 13x minus 22. All right. Now number 7 is going to work a little bit similar. So we have 24x squared minus, okay, now on the inside, we have 20 minus 0.8x squared. Now a negative times a negative is a positive. So 0.8 times 5, well, 8 times 5 is 40, but with one decimal, that's going to make it a 4. And then we have minus 1.6x squared. All right, so still on the inside, we're going to clean this up. So we're going to combine our, oh, I didn't write this in orange. I didn't color code it. Oh, well. So we're going to combine our x squared. So minus 0.8 and a minus 1.6. That's going to be a negative 2.4x squared. And then 20 plus 4, that's 24. Okay, so we have 24x squared. Be careful when you distribute, plus 2.4x squared. Negative times a positive is a negative 24. So we have these x squared terms. So we're adding them. 24 plus 2.4, that's going to give us 26.4x squared minus 24. And sometimes our answers don't look nice. They look kind of gross like this one does. Okay, but that's it. Okay, now this last step is going to be very important because this is what we're going to be needing to know when we deal with word problems, because we're going to have to translate. So for addition, these are some phrases that tell you about addition, subtraction, multiplication, and division. Okay, so they want us to write an algebraic expression. So the difference is referring to subtraction. So the difference of x and 8, all that means is you're just going to subtract x minus 8. The difference of 8 and x, well, that's just going to be 8 minus x. Now for part C, we have to be careful. It says 8 is subtracted from x. You're taking you're taking 8 away from x. So here you're going to have to flip. Okay, so subtracted from, this is going to tell you to flip the order. So it is going to be a subtraction, but we're going to flip this around. So that's going to be x minus 8. Okay. Now for number 9a, the sum means to add. So we're adding z and 3. So the sum of z and 3, that's just z plus 3. The sum of 3 and z, we're just adding 3 and z. Now for part C, 3 added to z. So you're adding 3 to something. So again, this added to is going to tell you to flip. So you're adding 3 to z. So you have to take the z first so that you can add 3 to it. Okay. Now quotient, and when we talk about division, you can write it one of two ways. You can write it as a division or you can write it as a fraction, and it doesn't matter. Okay, so the quotient of a and 5, well, that's just going to be a divided by 5, or you can say a over 5. Okay, the quotient of 5 and a is 5 divided by a, or you can say 5 over a. Okay, and this one is very specific. This says a is being divided by 5. Okay, which is similar to 10. So a is being divided by 5, or a divided by 5. Okay. Now 11a, be careful. It says twice a number added to 9. So twice a number, and we're going to add it to 9. So we're going to have to flip. Added to means addition, but we're taking twice a number, we're adding it to 9. So that means we have to start with the 9 first, and then we're going to add twice the number. So we let x or whatever variable you want. Now this one's different because it says twice. Well, twice what? It's twice the sum of a number and 9. Okay, so the sum of a number and 9, that's the sum of a number and 9, but it's twice this amount. So it's going to be 2 times x plus 9 in parentheses. Okay. All right. Now, the last one, number 12. This one can be tricky. It says the width of a room is 1/2 the length of the room. So in order for me to know the width, I have to know what the length is. So this means that W, if I translate it exactly as it is, the width is 1/2 the length. Width is 1/2 the length. Now, this is an equation, a statement, where we write W in terms of L. And that's exactly what the first part wants us to do. Write a statement representing the width of the room in terms of the length. So that's just going to be exactly what we said. W equals 1/2 L. Okay. Now, the second part says write a statement representing the length of the room in terms of the width. So, in other words, what we're going to do here, I'm going to take this equation, and in order for me to write this representing the length in terms of W, I'm going to solve for L. Okay, so if I solve for L, that means I need the 1/2 to go away. Well, the 1 is not an issue. It's the fact that there's the 2. So I'm going to multiply both sides by 2. So 2 times 1/2 is 1. So that means that the length is going to be twice the width. So length is twice the width. Okay. And that's how you handle that. All right. That's it for section 1.1. Remember, this is a review. So if you have any questions, just let me know.